This is Walter Jairo going through electrochemical cells from our last lesson. We said electrochemical cells, we have two types of electrochemical cells, the galvanic and electrolytic. Now we looked at galvanic cells and there are three types. We have dry cells, we have wet cells and fuel cells. Now we looked at dry cells in our last lesson, and we said that dry cell is a cell where the components are used and then you cannot recharge it. Once it is used, you cannot recharge it. We also said that it is also made of a paste. The electrolyte is made of a paste, which is a mixture of ammonium chloride and zinc chloride. Now we look at wet cells, which is the chemical reactions are similar, except that in wet cells we have the electrolyte is a liquid, and it is dilute sulfuric 6 acid, okay, which is the electrolyte. And then we also have the anode and the cathode, just like a dry cell. But the anode here is made of lead plates, which are arranged in parallel with the cathode, which is also lead plate coated with lead oxide. And like any other electrochemical cell, the anode is where oxidation occurs. So the reaction taking place at the anode is lead solid is losing electrons to lead ion, and then at the cathode, which is mainly made of lead oxide on the surface of lead metal, so lead oxide receives electrons, because this is where reduction occurs. It receives electrons forming lead ions and water. Now the hydrogen ions is from the electrolyte, which is part of sulfuric 6 acid, which is the electrolyte. So and at the same time, the lead ions that are produced in the two half equations taking place at the electrodes combine with the sulfate ions in the electrolyte to form an insoluble white precipitate of lead 2 sulfate. And we are going to see that this tends to form a coating on the surfaces of the electrons, and therefore reduces the efficiency. So it finds that after some time, you find that the wet cell will lose its electric production, it will lose its power, it will lose its efficiency, and so you find it has to be taken for recharging, or sometimes if the coating is too much, it becomes so impervious, then it finds that it finally gets spoiled. And so if you look at the overall, you want to look at the overall reaction taking place in the cell, then you have to add all the equations taking place in the cell to get the overall cell reaction. So if you add the three reactions taking place in the cell, then you end up getting the overall cell reaction, which is given here. And so during the functioning of the cell, then you find that you end up getting the lead sulfate, which we say is insoluble salt, and then the water. So in this process, we are saying the cell is discharging. So after some time, the cell loses its ions in the form of the dilute sulfuric 6 acid. So you have to regenerate these ions by recharging. Now the recharging process involves reversing this discharging reaction, so that you find that it is now the lead sulfate and water that will be the reactants on the other side, and they form again the original chemicals that are in the cell, that is lead solid and lead oxide, lead solid and lead oxide. I can make some correction here. This is supposed to be lead oxide. This is lead 4 oxide. So during recharging, you find that the original components are regenerated, so the cell becomes functional again. So the difference between the dry cell and the wet cell is that this one has got a liquid electrolyte, then the dry cell has got an electrolyte which is in the form of a paste, and it cannot be dry, because if it is dry then it will not be an electrolyte, it will not conduct electricity, because the ions will not be mobile. The overall reaction taking place in the wet cell is very important. You need to distinguish between discharging and recharging. Recharging is where now the chemicals in the electrolyte are undergoing decomposition to form the lead sulfate, lead 2 sulfate, and water. Then when the strength of the cell is reduced, the strength of the cell will be reduced because of the use of the ions and the use of the decomposition of the lead plate and lead 4 oxide. Once the concentration has reduced, then you can take it for recharging. And you can easily confirm that the strength has reduced by looking at checking the density of the acid in the cell. So recharging therefore is just the reverse of the discharging reaction. So that if you have, it's like a reversible reaction. The forward arrow is indicating discharging, and then the backward arrow indicates recharging. And then from here we'll go to the last electrochemical cell, last type of galvanic cell called fuel cells. Now fuel cell is different from dry cell and the wet cell in the sense that it can be reused over and over, because we only need to get the materials, the reactants, which are mainly oxygen and hydrogen. Once they are available, then you can produce the electricity through this cell indefinitely. It's not like the wet cell where the chemicals are discharged, and so the concentration of the ions reduces. This one can go on and on because of if you have availability of the raw materials, then the process will just go on definitely. Again, a fuel cell is also quite advantageous because it is environmental friendly. The waste materials is not so much poisonous to the environment, which is mainly water. It's just mainly water that is produced during the reaction. So it is advisable that we can get the fuel cell and use it, because it has a lot of advantage. The main ones being that it can be reused over and over, and then it is also environmental friendly. Now, which type of reaction takes place in this cell, as you can see? Now, the electrolyte is aqueous potassium hydroxide. And so at the anode, which is the negative terminal, that is where oxidation occurs, then we have the hydrogen gas reacting with the hydroxide ions, which is part of the electrolyte, and then it will produce water and releases electrons. These electrons will flow to the cathode, where oxygen now reacts with water, accepting the 4 electrons from the anode, then we get hydroxide ions. So you can see that the hydroxide ions is being regenerated even during the reaction. So it also confirms that the electrolyte can be used for a very long time without being exhausted. And so the 3 types of electrochemical cells, the galvanic cells that we have talked about, we have said is mainly used to produce electricity. We use them to produce electricity, and dry cell and fuel cells are more convenient, as you can see, because the dry cell can be portable, the wet cell can be recharged, that is another advantage, and then this one can be used over and over so long as there is availability of raw materials. And so that will now end our topic of electrochemical cells, and then the subtopic on galvanic cells that we have already discussed, the 3 of them. So we expect now to go through the electrolytic cells. That is now the last part of our topic, electrochemistry. Thank you for listening. Let's meet in our next lesson where we'll be discussing electrolytic cells.